Hmm. Okay, so camera first, I'll switch on the camera. Okay, so I'll explain lecture 28. In lecture 28, we are going to see some more examples based on polynomials, and these examples are very important. Two examples I have taken. So these two examples, if you understand, you will be all right with this topic, and this is the last topic of ODE, and then we'll move to PDE. And after this lecture 28, I will discuss one small topic which is the extension of this topic, but that topic we don't have to do for GATE exam, but just note down the topic in your notebook. So in this example, d2y by dx square plus 4 dy by dx plus 5y is equal to 3x minus 2. So see, one thing you can do with this 2 you can treat separately as a separate number, right, like we have treated in previous lectures as a constant number, or 3x minus 2 you can combine together as a complete polynomial. And with this topic, like whatever concept we're learning for this topic, you can combine, I mean you can solve this 3x minus 2 together. So in two examples, in first example I will combine this 3x minus 2 together, and in the second example I will treat that constant separately. And what is your main focus here? How to find out particular integral pi for this thing. It is very easy. Always remember, whenever any question is given to calculate CF and pi, what is your first job? First job is you have to find out your FD equation. What is the name of FD? Auxiliary equation. So FD is equal to d square plus 4d plus 5. What is d square? What is 4d? What is 5? This is your d square, this is your 4d, this is your 5. Okay, done. What is your, okay, now you substitute this to 0. That is our work. Either you find CF or you find phi. You have to do this. Put to 0, find out roots. So we got two roots, m1 and m2. So minus 2 plus minus I. So it's like if you compare with alpha plus minus beta I, then your alpha is minus 2 and your beta is 1, right? So with this 2, you will find out your CF. You know how to find out CF. Simply I'm spending time here. You know how to find out CF. Once CF is done, then you move to PI. Like I said, there are two ways to calculate PI. In one way, you can consider this minus 2 as a separate number and find pi separately for minus 2 and separately for 3x, and 3x part you will understand in this question. But I am saying 3x minus 2 will combine together as a final polynomial, and we will learn. So always remember, whenever you are solving any pi question, first of all you have to write down one operator. This is not for GATE exam. This kind of format is for your university exams. Okay, in GATE exam you can be faster and you can skip this step. You can directly jump to, then this operator, this is your right side. So before that you applied the operator 1 by FD. Then this FD, what is this FD? D square plus 4D plus 5. In question, in lecture 28, we did not get situation where D square plus 4D plus 5 was remaining as it is. What kind of situation we got? Somehow this guy was being cancelled and it was coming as 1 by D in one example, and it came 1 by d plus d in another example. So this question was easier there. But here when d square plus 4d plus 5, we are not able to do anything. In that case, what will you do? This is the main key point of this lecture. So d square plus 4d plus 5, if you are not able to solve, I mean if you are not able to link like this or like this, what you have learned in previous lecture, then what will you do? What is your fundamental of this? Your fundamental is you are looking for 1 plus x or 1 minus x type of bracket and over plus 1 or minus 1, so that expansion we can do. So what will you do? But whenever d square plus 4d plus 5 is not able to get form like above, then it is simply goes like this. Like what? Like this. You take 5 common. What is 5? Whatever is your constant term, this is the 5. It can be 5, it can be 6, can be another number. That number you take common, and whatever is remaining, that will take this form. So in this form you have got something. What did you get? 1 plus something format you got. Okay, what do I mean? Meaning is 1 plus something. 1 plus something means this something is your x type thing. So 1 plus x format you got. This 5, no problem, let it be there. Okay, so because we need 1 plus something format. Why? Because then only we can apply 1 plus x power minus 1 or minus 2, and then we can expand. So see here. So first I wrote here FD, then I wrote the FD value, then I took F5 common, and then I made this format. And I am combinedly learning 3x minus 2. Okay, then what is your step? You have to take this entire bracket up, so minus 1 will come here, and then you will go for expansion, correct? 1 minus x. So what is this? 1 plus this, consider this as x, 1 plus x power minus 1 expansion. You know 1 plus x power minus 1 expansion, I told you in last class. 1 minus x plus x square minus x cube. So according to that, you will be expanding this bracket. Consider this total thing as x. Now how long you will expand? For that also I told you a trick. See, you check power here. If power is more here, like suppose x power 6 is there, x power 7 is there, x power 5 is there, then you will expand the term so that you will reach d power 3, d power 4, d power 5. Last power should match with x power. Okay, but currently d square itself is bigger power than x power. X power 1 is there, na? Here you have x power 1, and here directly you have x. So only, no need to expand completely, only first term, second term, means 1 minus x, means 1 minus this bracket itself is sufficient. So when you expand this, 1 plus x power minus 1, 1 minus x plus x square. So 1 minus x term you write, that's all. So see what I'm writing here. In this bracket 1 should come. I'm not writing 1 because in that one I will multiply 3x minus 2. So suppose that I multiplied here and this bracket I framed. Then minus this entire thing, d square plus 4d plus 5. So d square is here and 4d is here. In that also I multiplied 3x minus 2. Should I go for third term expansion? No need, because in third term everything will be higher. So if you differentiate, answer will come 0. So no need to go. Okay. Then you can see here d square means 2 time differentiation, d means 1 time differentiation, and inside the bracket 3x minus 2 is hidden. I'm not writing, just 2, because statement will be lengthy, but you have to write in your notebook. So this d will tell you differentiate 1 time, so 3 will come, this 2 will become 0. This d square is telling you this bracket 3x minus 2 you have to differentiate 2 times. So 1 time when you differentiate 0, 3 will come, then again differentiation, 3 will also become 0, so overall 0, and 4 into 3 will come, and this minus 5 will be remaining as it is minus 5, and in the bracket 3x minus 2 is remaining, so that 3x minus 2 I wrote here. Okay, and this thing is here. So whatever is the final answer, that became your particular integral. So y is your general solution or complete solution, that is sum of CF and PI. So CF is here, PI is here. This was the CF answer. That's all done. Question done. Now I'm taking second example. In second example, I will tell you that you can consider this 3 separately, and you can solve PI differently. And this x square, what you see here, this x square. Now here I will tell you, don't expand only first term and second term. You also expand third term. Why? Because you will get the feel when to expand till first term, when to expand till second term. So d square y by dx square, d2y by dx square minus 5 dy by dx plus 6y. So what is the first job? Make your auxiliary equation. Second job, that auxiliary equation put to 0, find out your roots. m1, m2, 2 roots are 3 and 2. Roots are real and different. So what is your CF? A e power m1x plus b e power m2x. That part is also done. Now look for right side part. So in right side part, 2 parts are there. One is x square, another one is 3. So I will teach you here. Find out separately pi for x square, find out separately pi2 for 3. So pi2 for 3 we have done in so many lectures earlier also. How to find out a particular integral only for a constant number? What do we do? That constant number we multiply with e power 0x, and this 0 will behave like a. Done. So for 3 you know already, we have done in previous lectures also for constant number, so you will not find any difficulty here. So 3 into e power 0x, substitute here fd operator, d value you substitute here, fd value substitute d square minus 5d plus 6, put 0 there, because d we replace with a value is 0. So finally 1 by 2 will come. So we got 1 by 2. I'm not spending time here because you know how to calculate this. Now pi1 for x square, let's see how. Always remember, whenever you are finding out pi, what will you do? You will first write the operator part. This part is not for GATE exam. You can skip this part. You can directly land here if you have good practice. But in university exams, you have to write this step, then you have to land to the next step. Anyway, fd value is known to us, d square minus d square plus 5d plus 6, sorry, d square minus 5d plus 6, done, and x square as it is. Then again you can see here 1 by d is not coming, 1 by d plus 1 is not coming, those things what we have seen not coming. What will you do? Take 6 common. So taking 6 common we are learning in today's lecture. Taking 5 common, taking 6 common, we get it. Why? Because intention is 1 plus x format we have to make. We made 1 plus x square, 1 plus x format we make. Okay, then what is next step? Take the denominator in the numerator. So minus sign will come. Okay, now see here. See here. When you will do 1 plus x power minus 1 expansion, what is coming? 1 minus x plus x square minus x cube coming, right? How long will you go? So for that you have to check what is the function. Function is x square. In previous example function was x, so only one term I went, but here this time it is x square, so 2 times I will go. So here, because in first term d square is coming, and in second term when you do whole square now, so there also you have d sitting, that d will become d square. So it means what? Second term is visible, it is containing d square, but third term is not visible that it is containing d square. But when you will write third term and expand, then you will see that, oh, even third term contains d square. So that's why I have chosen this question for practice. So see here, this one I wrote here, and but only this much is enough? Answer is no. Why? Because even third term, even this term contains d square after expansion. How will you know? D square minus 5d whole square is there. Expand, a square minus 2ab plus b square. So a square means d power 4, that is not needed for us. 2ab, d power cube will come, I mean d power 3 will come, that is also extra, it will make answer 0, no need. But when you write b square, 25d square will come. Okay, so in first term also you have d square, in second term also you have d square. Now almost simple. What will you do? This x square you multiplied with 1, multiply with d square, multiply with 5d, and multiply with 25d square. These higher terms you ignore because they will make them 0. They will make that x square 0, because d power 4 means 4 time differentiation. X square when you differentiate 4 times, 0 will come. D cube means 3 time differentiation, 0 will come. So no need. Okay, so in this step you can see here, correct? X square multiplication in 1, x square sitting here, x square sitting here, x square sitting here. And you know what to do? What will you do? D square means 2 time differentiation, d means 1 time differentiation. Do that. So here 2 time differentiation, 2 will come, right? So 2 by 6. Here x square when you differentiate 1 time, how much will come? 2x will come. So that 2 and 6 you can cancel, 5 by 3 will come. Then here 2 times differentiation, what will come? 2 will come. So that 2 and 36 you can cancel, 25 by 18 will come, right? So this became your pi. So simplify this little bit more, simplified in this way, right? So what is your general solution or complete solution? CF plus pi. So CF is CF, pi in 2 parts, pi1 and pi2, correct? So both we wrote here like this. Oh, I think 1 by 2 I am missing. Okay, no, it is here. All right, this should be like this, guys. I made a mistake. This should be like this. This 1 by 2 is separate because this is your pi2 for 3 we calculated now. For 6 I'm sorry for something. Let me check. This 1 by 2 you can see here, this 1 by 2. So okay, that part I should write bracket, I should close bracket here itself. Bracket should not be here. Anyway, all these terms, all right. Now last type, what you don't have to do for GATE exam, nothing here, no explanation, no question, simply your e power x will be multiplied with any other function of x. It can be e power x into x square is the function of x, e power ax into x square, like e power 3x into x square, e power 3x into sine x, something will be there. But you don't have to do that for GATE aerospace exam. You can skip this, but just note down, if this kind of question is coming by mistake, then what will you do? Because this already a lot of things you are preparing now. So d value you will replace with d plus a, that's all. Means whatever is the coefficient of x in e power, that is your a value, you know that. So d you will replace with d plus a. So when you are writing the operator, then how are you writing the operator? Pi 1 by fd and the function. So function is e power x into fx. e power ax into fx. So from e power ax, find out a and replace this d with a, and then you go for your mathematical solution. One extra knowledge here, because this can be used in upcoming exam of ODE. If e power I theta is there, formula is cos theta plus I sin theta, right? Now, a special thing I want to tell, for theta is equal to pi, cos theta will become -1 and sin theta will become 0. Take this minus and left side. So e power theta plus I is equal to 0 is known as Euler's identity. That's all, only this much you do for ODE. Now next will be for PDE, and every year, not only this year, every year only this much you do for ODE. But again, if you have more time, then the last topic what I said, you can practice some 4-5 questions from that drive what I told you to practice from that book. Okay. Anyway, this is fine. Now you go for lecture number 29. From there we'll start PDE, partial differential equation. So